and I have number 13. So on number 11 and 13, what's the, besides the obvious differences, like I know that one only had, like 13 only has one variable, and the number 11 has an M and an N, but there's like one really big difference between the two of those things. Like, what do you notice that's different?
Number 16 is an equation.
Exactly. So that's a really important difference for this particular worksheet. To notice that, like number 11 is just an expression. So because it doesn't have an equal sign, you know that all you're going to do for this one is factor it. But for number 13, because it's got an equal sign, we are going to have to factor it, but then we have to take an extra step and we need to solve it after we do that. Okay? So let's start with number 11. So what's the very first question you're going to ask yourself when you are...
Is there a GCF?
Exactly. So is there a GCF?
No.
So there's not anything we can factor out of 28, 21, and 28?
Oh, wait, no, yeah.
Okay, you're right that you can factor an M out of each of them. I agree with that. Nothing else? Like, what about the, what, no, you got, there's a number you can factor out of that 28, the 21, and the 28.
Oh, 7?
Yeah, exactly.
Okay.
So we're going to factor a 7M out of each of them. So if I factor that 7M, that greatest common factor, what will be left in my first term after I factor a 7M out of there?
4M N squared.
Yep, because I factored one N out, so that's what I had left over there. What about in my second term? What have I got left over?
3N.
Okay, so plus 3N. Is that what you said, right? Because we had an N and we factored out the N. Okay, and then what's my last term?
-4.
Yep, good job. Okay, so then what do you need to ask? Oh, sorry. What do you need to ask yourself next?
Is it a quadratic trinomial?
You could do that. So is it quadratic? We know it's a trinomial. Okay, so what might be a little bit confusing, because I don't know that we've done one exactly like this. Okay, so technically, do you agree with me that there's a 1 exponent with that M right there, right?
Yeah.
So that means that this first term, even though there's a 2 with the N, because there's a 1 there also, the degree for that first term actually isn't quadratic. That's a 3 instead.
Okay.
Which means that this is actually, even though there's a 2 there, because you've got the extra exponent 1 to go with it, that means the first degree is 3, so it's not going to be quadratic. So what's next?
Sorry.
Oh, you're fine.
Is it special?
Is it special? Right. So do we have any like term, or so is this or that? Well, it actually has to be both. Are those perfect squares?
No.
You're right. This one's tricky. This one's this one's a perfect square, and the first one is almost a perfect square because of that 4 and that n to the second. You can do like 2n and 2n. But what's throwing that off from being a perfect square is that m. Like there's nothing you can multiply by itself to get that m. So it's almost special, but not quite. So it's not quadratic, it's not special. We already ditched the GCF. What else do we need to look for?
Is it 4 terms?
Yeah, you're right. Is it 4 terms?
No.
It is not 4 more terms that can be grouped. So we've gone through our whole list of questions. We don't have a GCF. It's not quadratic. Excuse me. It's not special. So that means that we're done. The only thing I need to double check and make sure is that it's an expression. So because it's an expression, because there's no equal sign, all we can do is factor it. We can't actually solve it. So all we'll be able to put in there is just the factoring. So I'm going to pull up the Google form I don't know if you've been using those or not, but if you have, and so we probably know we're right. So now number 13, I'm going to turn my attention to that one next. So how do you know what characteristic of this problem is it that's going to tell you that you're going to solve it instead of just factoring it?
Oh, is it equal sign?
It's got that equal sign, right? So the first thing we need to make sure is that it has to be solved for 0. So like, for example, number 14, which we're going to actually check out in a second. Number 14 is an equal sign, so we know we're going to solve it, but it's not set equal to 0, so we're going to have to manipulate that one a little bit. Okay, but 13 is already set up perfectly for solving because it's already set equal to 0. So what does that mean our very first step needs to be as we figure out what we need to do?
Wait, could you ask that again?
Yeah,
Sorry.
so we're basically going to ignore the equal sign for a minute, okay? And we're just going to treat it as if it were an expression that we were just plain old factoring. So forget about the equal 0 for a minute. So what's the first thing you're going to do?
Does it have a GCF?
Yes, and does it have a GCF?
Hold on. Yes.
It sure does. What is that GCF?
6?
Yep. So we're going to factor a 6. Is there anything else we can factor out of there?
No.
All right, so after we factor out that GCF, what do we have in the little remainder spot?
X to the second power and negative 36.
So then we've got an x squared minus 36. So then what is our next question we need to ask ourselves?
Is it quadratic?
Okay, is it quadratic?
Yes.
Okay. So what should we look at next? So we see it's quadratic. Or actually, this next thing, we kind of could have done that first, too. Before we looked for quadratic.
Wait, hold on.
I'll give
I'm
you.
trying to figure out how to say it, you know?
I'm giving you a clue right there.
Where I can't. I think.
Oh, snap! I'm sorry, I forgot. You couldn't see my duh. You're gonna have to yell, fuss at me, because sometimes I forget that stuff. All right, so there's my clue right there.
So you have to like separate the two.
So let's see if it's special. Yep. So let's see if they're perfect squares. So what about that first part? Is it a perfect square?
Yes.
Yep. What about the 36?
Yes.
Yep. And you've got subtraction in the middle, and you've got the middle term canceled, so that means that it's going to be special. So this one's one of the easy ones. So remember, you just pop open those binomials, and it's going to be x minus 6, or x and x, 6 and 6. And because of that subtraction, it's going to be x plus 6 and x minus 6. Now that GCF, that's a lot of 6s, man. This is a very unlucky problem. So that GCF is still chilling out there. Okay, he's like that loser he's there. He's not really doing anything, but he's there. So if you type it in the way it is right now, it's going to tell you that it's wrong. Because the whole point in this case of factoring was so that we could actually find the solutions. Do you remember how to find the solutions from here? If you don't, that's cool. That's why you're here.
Yeah, I don't remember.
Okay, so now I'm going to stop ignoring that right side of the equation, that equal to 0. And so this is where we need to find the zeros. We need to figure out what value for x. So either this binomial needs to be equal to 0, or that binomial needs to be equal to 0. So either x plus 6 is equal to 0, or x minus 6 is equal to 0. So the only difference is that we're having to take a step further after we factor it, and we've got to solve for 0. So for this one, obviously, what would x have to be so that x plus 6 is equal to 0?
0.
Would you say what plus 6 gets you 0?
Oh, wait.
Yes, it would be negative 6. All right, so negative 6 is one of your solutions. And then what would this value for x be so that x minus 6 is equal to 0? Yes. So your two solutions are negative 6 and 6. So to type it in the Google form, you're going to do those brackets that I cannot draw. The Google form's a little bit picky because it wants you to do the smaller one first. Even though in real life it doesn't matter, it just makes it easier for it to check. So we'll type it in there real quick, make sure, and voila, we got it. So we know that that one's right. So basically, you're not doing anything new today. It's just that or from what you were doing from last week, it's just that you have to recognize the difference. Like, is it asking you just to factor, or is it asking you to solve? And obviously, if it's not an equation, you can't solve it because it doesn't give you anything, to set it equal to. So number 14 is going to be similar, except so we know we're going to solve it. Tell me why you know you're going to solve it.
Because there's an equal sign?
Because there's an equal sign, exactly. So what format, though, does this need to be in before you can really start factoring it?
There has to be a 0?
Yeah, we have to have it set equal to 0. So what, my friend, could we possibly do to get this side of the equal sign equal to 0? In a hot minute. So all we're going to do is we're going to get rid of that minus 3 by doing the inverse, which is a plus 3. Obviously, if you cancel out that...
I can't see the 3 again.
Ah, shoot. Thank you for catching me, my bad. Okay, so I'm going to add 3. And obviously, you remember what you do to one side, you have to do to the other. I know we can't do 2x squared plus 3, so I'll show you what we'll do with that in a second. And then we also need to cancel out that minus 5x. What would cancel out a minus 5x?
Plus 5x?
Yep. So we'll do plus 5x over here. Okay, so now if you look on the right side of your equation, that's obviously going to cancel, and that is obviously going to cancel, so that's going to give you your 0 that you need. And then you know that over here on the left-hand side, the 2x squared and the 3 and the 5x are not like terms. So you can't actually combine everything. So you're just going to rewrite it as 3 separate terms. You just need to make sure that you put it in the right order so that 2x squared comes first because the exponent of 2 goes in the front. And then the 5x is going to come next. And then the 3 will be last because you always do it in standard form with, the x to the second first. So now that we've moved that 3 and that 5x over to the other side of the equal sign, now we can actually start the real work, which is factoring, since it's set equal to 0. So what would be the first thing you need to check out?
Is there just 0?
Yep. And is there?
No.
Nope. Okay, so what next?
Is it quadratic?
Is it?
It is?
It is a quadratic trinomial. Yep. So then what else do we need to check out?
Is the quadratic like 0? I mean 1.
Yeah, so is A equal to 1? Is that what you meant?
Yeah.
Yeah. Is A equal to 1?
No.
No, so we got to do the crappy one. That's a lot of work. So what's the strategy we need to use for a quadratic trinomial when A is not equal to 1?
Basing.
Yep. So this part I'm going to kind of whiz through because I have a feeling you'll probably be fine. So we'll do our A times C. We'll get 6. So you're trying to figure out what do you multiply to get 6 that you add to get B. So what are we going to multiply to get 6 that'll add to get 5? So give me some factors of 6.
1 and 6.
Right?
2 and 3.
Okay.
Yeah,
that's it.
Yeah.
Okay, any of those add up to 5?
2 and 3.
Yep. So because 2 plus 3 is equal to 5. Now what do we use that 2 and that 3 for? What are we going to do with it?
You put them in the parentheses with the x's.
So we're going to, so now
Oh,
if,
wait a minute. Yeah.
yeah, so we got to use it to break up that middle term. So we still got to do more work. That's why this one's the worst. So you got your 2x plus your 3x. I'm going to bring down everything else. And then what, ma'am, is the whole point of taking those 3 terms and splitting them up into 4 terms?
So you can do factoring by grouping.
Exactly. So what do you want to factor out of that first group?
2x.
Mm-hmm. And then what do we want to factor out of the second group?
3.
Okay, so I'm going to factor that 2x out of there. I think you can see where we're going with this probably at this point. So that's going to leave you with x plus 1. If we factor that 3 out of there, that leaves us with x plus 1. We know we're on the right track because these are the same. So we're going to factor that common x plus 1 out of there. And then you've got the 2x plus 3. So we factored it, but now because this is an equation, we still need to solve it. So I haven't really done anything with that equals 0 yet. So now I'm going to stop ignoring that equals 0. And because of the way multiplication works, obviously to get something equal to 0, either that one's got to equal 0 or that one's got to equal 0. So we're going to set up 2 problems. So we're going to do x plus 1 equals 0, which means that one of the solutions could be a negative 1, right? Because negative 1 plus 1 would be 0. Then we have to set up 2x plus 3 equal to 0. So you subtract 3 from both sides, and that leaves you with 2x is equal to negative 3. Kind of running out of room here. And then divide both sides by 2. And x is isolated now. We want to just leave that as a fraction. So your 2 solutions are negative 1 and negative 3 over 2. So if I go to type it in there to make sure I'm right, which one of those is smaller, negative 1 or negative 3 over 2?
Negative 3 over 2.
Exactly, thank you. Yeah, because it's like negative 1.5, which is actually smaller because they're negative numbers. So do your brackets, negative 3 divided by 2, comma, negative 1, and brackets. Hopefully this is not going to scream. Yep, so we got it right. Do you want to try another one, or what do you think? How you feeling so far? Most of the problems I got is that stuff like they forgot they had to take a step further, especially if it ended up being something like, here, I'll do number 16 real quick. Number 16 was one I got a lot of questions about because, okay, so if you look at it, you're going to notice it's special because you can do 2x and 2x, and here you can do 4 and 4, and you've got that subtraction in the middle, so you know it's going to be special. So you've got 2x plus 4, and then 2x minus 4. So a lot of people were getting this one, or they thought they were getting it wrong for a couple reasons. First of all, make sure when you type it into the Google sheet, the directions or the Google form, it says whichever binomial has a smaller constant, put that one in first. So some people were just putting it in backwards, like, so, you know, doing that, for example. And then some people were doing a step too much, and they said, oh, okay, 2x plus 4 is equal to 0, so I need to solve it. Because is there an equal sign in this particular equation? Or in this, no. So don't do extra work and solve it when you're not supposed to solve it in the first place, and then message me because you're like, oh, it's saying I'm wrong. Because all you're going to do here is factor it. But you do need to remember to put the one with the smaller constant in first. So if you were actually typing it into the form, you would type that number first.